Dear aspirants, welcome to my channel. This is a model question paper 2, Electronics and Communication Semester 2, Applied Electronics 1, subject code is 25 ECE21I, part D questions. So each question carries 10 marks. If you attend 3, you will get a 30 marks. So each question will be an 10 marks. Describe the atomic structure of silica, germanium, illustrate how their atomic structure influence their electrical conductivity and use in a electrical device. So coming to in the introduction, these are silica and germanium are semiconductor material. It having a trivalent elements having a 4 valency electrons. It's having a both each is having a 4 valency electron that will show you in the diagram. In the periodic table, it is a group. This group belongs. Coming to an atomic structure of a silica, it is silica atom, it is a 14 numbers, atomic number is 14, number of electrons are 14, but electronic configuration 2, 8, 4, and silica which is having 4 electrons in a outermost. This is just a silicon structural diagram. This is the silicon number and electronic configuration, valency electrons. This is silicon, there is a surrounding. You just see the number of valency electron 2, 4, 8, which will be around in the silica. This is the diagram you can represent. This is an covalent bonding of silicon. There's a covalent bond they given, the dotted which will give you sharing the electron, how it will be the sharing the electrons in this diagram. You can write this diagram also. Next will be an atomic structure of germanium atoms. Germanium atoms which the atomic number is 32. Number of electrons revolving around 32. Okay. The configuration, coming to the configuration, it is having 2, 8, 18, 4 and it is having a 4 valency electrons. Coming to the structure of germanium, you just see the atomic number and electronic configuration and valency electrons. So you just see how the electrons which will be revolving around here inside and number of electrons which will be revolving around. You can write this diagram and based on the number of electrons you can write it. The outermost there is a 4 electrons and inner 8, 18 and 2 electrons. It will going to distribute. Okay, coming to a covalent bond, how it looks in the germanium, you just see the covalent bond. It is a bond and each electron, that is this red color which represent electrons sharing for all, how they are going to represent here. The influence of electrical conductivity. Silica germanium atom, it is a valency electron from covalent bond with a neighboring atom, how in the diagram representing. And at the room temperature, some covalent bonds break due to heavy heat energy. Okay. This produce free electrons and holes. When the free electrons and holes are charged, these act like a charge carriers. And silicon germanium, it's having a good conducting electricity moderately, that we call it as a, that's why we call it as an semiconductor. Why we call it as a semiconductor? It is conduct the electricity moderately, that we call it as an a semiconductor. Coming to an uses of silica in electronic devices, which we can use it for diode, transistor, IC, ICS, solars and microprocessor. Same way germanium used for low voltage devices, high speed transistors and special detector. You just write a important point about the question. So both silica germanium are semiconductor and which it is having a both which having a 4 valency electrons. It conductivity increases when increase with the temperature. Silicon more commonly used for use because better stability. The atomic structure controlled by the electrical behavior of the electrical devices. The next question, describe the important DC load line. Operating point, that Q point is BJT amplifier. Illustrate with a diagram. So coming how it looks, DC load operating system of QP point in a BJ amplifier. So this is the amplifier circuit. R1, RB and RC. IC will be there. So you just see the diagram. Okay. This is diagram for amplification of BJT amplifier. So VB, VBE and VC voltage, collector, emitter and base. Okay. So RB and RC, this is the diagram will represent. You just see the diagram. Okay. And the equation, based on that equation has given VCC is equal to VC is equal to VCC minus IC and RC. When IC becomes 0, so VC is equal to VC is a cutoff point. So IC becomes 0. When VC is 0, how the saturation condition? You can write this formula load equation, that is also enough for the exam. Line, what will happen? Right line drawn output characteristics of a transistor, which will show a possible values of collector current of IC and emitter current of voltage. How the Q point is operating? When the Q point DC line intersecting the transistor, the characteristics we call it as an operating point or Q point. When the DC line, when the where the point, the DC line which will be intersect with the transistor, that we call it as an Q point. It will be represent 0 with a signal condition of the transistor. So coming to an importance of QP point, it will ensure faithful amplification signals which we can use, and we can prevent the deterioration of output waveforms. You can keep the transistor in active region, which will be provide a maximum signal swings, and it will give the stable Q point, improve the amplification performance. So okay, what is the next? We'll go important of what is an important of DC load line? Importance of DC load line. It helps determine the operating region of transistor used for to find the Q points which show the relation between IC and VCE. It will be helpful for amplification, signal and analysis. Indicate cutoff and saturation region. And this Q point should be near to the central load line, and improper Q point will cause a deterioration. Okay, load line connected to saturation and cutoff points only. The active region will be used for amplification. Next will be a DC load line essential for transistor bias. Next, explain the construction and working principle and characteristics of enhancement type of MSFET and with a symbol and application. This is coming to here the diagram which is going to represent a construction diagram. NP channel, there is, you just see the diagram how it look. It is having a gate source. It is having a gate source, silicon insulator, SiO2 insulator, drain and PN type of substrate body. This is the body they are going to represent. This is the diagram. This is an diagram. Okay, you just see the diagram. And symbol, what is the symbol of enhancement? This is a symbol of enhancement type. Okay, just see the symbol of. Coming to intro. In the introduction, it is a type, we can use it for voltage control semiconductor device. So only we can operate, how you are going to operate with help of when gate voltage is applied, we can operate, which we can usually widely use for switching and amplification circuits. So coming to an construction, the construction of enhancement of MSFE, it is having a terminals, gate, drain and source. So okay, NP channel we can use it, it is having a light dropped P type of subtraint we can use. Okay, when two heavy loads dropping, okay, in NP region which form a source and drain, and it get insulated from subtrant by thinning silicon dioxide layer. There is no physical channel exists between source and drain insulae. How it will be working principle? Coming to an working principle. This is an working principle. So this is the condition cutoff region. Cutoff region means ID becomes 0. It is an device off. When small r 0 gate voltage, there is no inversion the layer formed. There is no existing will be takes place. The diagram look like this. You just see the diagram how it looks, and symbol also look like this. Coming to an explanation, working explanation, when a gate source voltage Vs is 0, no channel formed, there is no dry current will be 0. If it is positive gate is applied, the electron attract towards the gate region, inversion the layer is formed. When a current start flowing the drain source, the gate voltage is increases channel conductivity and drain current. So coming to the next condition. So this is the next condition is given, channel formed and conduction. Okay, so here you just see the conduction how it looks. Okay, the positive voltage greater than the attractive electrons to positive surface formed a N type of inversion channel. Here the device is an on. When the electron from source to drain, when the device is on, we are applied VDS. So this is the diagram looks like, this is the symbol for that. Next, enhance characteristics of enhancement MSFET transfer characteristics show the relation between the ID and VGS. The dry current increases rapidly after threshold voltage. So, what is the dry characteristic? Drain characteristics. It show the relationship between ID and VDS. So, device will be operate in a cut off region and a ohmic region. Okay, and also saturation region. Coming to an application, electronic switching circuits we can use, power amplification, CMOS integrated circuits, motor control circuits and digital electronics we can use. If the content is useful, please subscribe my channel, share and support. Remaining questions I am going to upload next video. Thank you.